you know how light travels? Well, of course, Newton told us that light travels in a straight path. Well, he's right, but don't you know that light can also travel in a curved path? Are you sure about that? Well, yeah. This idea is actually formulated by the great scientist Albert Einstein. Let's learn more about it. Einstein thought that if an object falls towards the Earth, the object would experience weightlessness since gravity would be the only force acting on it. And this would be no different than being weightless in space. Observe this. If you're in a room of a spaceship moving at 9.8 meters per second squared, your weight will be the same as when you were on the surface of the Earth. Acceleration inside the spaceship will be indistinguishable from being stationary on Earth. If you didn't know that you're in a spaceship, you will just then presume that you're still on the Earth. There'd be no way to tell the difference. Or would there? Einstein thought about this by asking himself if there's a way to tell the difference. If you're riding in a spaceship accelerating at 9.8 meters per second squared and point a flashlight on one side of the room, Einstein found out that the height of the light on the other side would be shorter. This is because you're rushing up in an even faster speed as the light propagates across the room. And since the room is accelerating upward at 9.8 meters per second squared, then the light beam would appear to curve downward. However, if you're on Earth, this will be no different because the acceleration of the spaceship should be the same as the force of gravity on Earth. And in space, Einstein hypothesized that perhaps a straight line is not the shortest path between 2 points. And with the presence of mass and energy, space becomes curved. Hence, the shortest path that the light can take is a curved path. Let's take this model as an example. This fabric represents space. If you put a heavy object at the center, what can be observed? Now I will let these balls roll on the fabric. You will observe that they are somewhat revolving around the heavy object. These balls are the planets that surround the Sun. If a light ray comes from a distant star, Newton's law predicts that it will move in a straight path like this. On the other hand, Einstein's theory states that the light ray will follow a curved path. If this is the case, the light coming from the star will pass the Sun and would bend through space, and the Sun would appear to us on Earth, apparently at this location. This is how Einstein visualized his concept about space, light, and his general theory of relativity. Do you get it now? So light can travel in a curved path. That's amazing!